Hi guys, in this video I will show you how to use a tool for detecting memory leaks. It's called valgrind. Unfortunately it's not installable on macOS, so I will show this on a remote machine, on a Linux machine at school, to which you also have access. I will first show you how to use this tool in general, and then I will show you how to detect memory leaks in our project. Usually detecting memory leaks in a project means that you have to start over. But fortunately, you will see that all these memory leaks are just things that we have already on our to-do list, so we already know that we have to care about them. And I will afterwards show you how to fix these problems. Actually, all problems except of one, which we will fix later with a certain design pattern that I will mention in the end of this video. Okay, let's start with some simple test for valgrind. I simply want to allocate some memory and first release it. Something minimalistic. So I just allocate memory for one integer, and here I will not check whether this works. I want to keep it simple here, and I first release this allocated memory block, and then I simply call valgrind and pass the executable as first parameter. And then we see that there is no memory leak possible, so that's good. And now I remove this or make it a comment and do this again. And now we should see that we have a memory leak. Yeah, definitely lost 4 bytes. Now let's use this option that was suggested by valgrind, and then we should see where we caused this problem. So we see a malloc was called in function main, and the memory block that was allocated by this call was never released. Now I want to compile again with a option -g. This will cause the compiler to generate some additional debug information, and this debug information generated by this -g will allow us to see actually the line number where this call was made in function main, so in line 6. So here, this is the guy that causes this memory leak, and this option of course is now interesting for the project, so let's add it to the defaults. And then I recompile everything in this project with that option. So I first have to clean and then recompile. Okay, now let's see what memory leaks we have in the calculator currently. We should have memory leaks from ustrings, because this pool of unique strings never gets released. So here I have to type in something. And now let's see how we can track down the problem. And another problem will be the string class. The lexer never releases this string object. Okay. Okay, now I do not see any line numbers. Let's also use this option here. And do this again. Okay, now we do get the problem. So this clear string called in get token has a memory, and this never gets released. And okay, we know that. Now I do not see here any problems from unique strings, because this calculator doesn't have so far the variables. I have to use another test program that actually uses unique strings. Here I also have to type in thing. And yeah, then we see we also have this problem in the unique strings. Okay, and this needs to be fixed. I will do this on my local computer. The idea to solve this problem is to manage a list with callback functions. So that's simply a list where the list elements are function pointers. There will be one function, finalize register, which allows to add a new function to this list. And of course, this could be a function for cleaning up memory. And there will be actually two functions for making sure that each of these functions will be called. The function finalize will simply iterate over this list, call each of this function, and it will also release the memory for this list itself. So the idea would be to make sure that finalize gets called before the program terminates. So that should be the last statement in function main, for example. But also every other exit point should have this call to finalize. That means, for example, if we allocate memory, check whether we have a null pointer, and we do have a null pointer, then we not just simply should call exit, we should call finalize and then exit. To make this a bit more convenient, we provide another second function, finalize exit, which is exactly doing that, calling finalize and exit. Now let me show you how to implement this data structure. It's actually not that difficult, and how to integrate this then into our project so that, for example, the unique strings will be released before the program terminates if finalize gets called, and also this string object in the lexer should be, of course, released. So let's begin with the header file for finalize. So first include card, of course, with the usual pattern. And then we can declare these functions. This function for registering a callback function. So function with return type void and no parameters. And then a function for calling all registered callback functions, finalize, and one function which is calling finalize and then will exit with some given exit code. Now let's copy these declarations, and then I can begin with the implementation. I will later write a test program for that. So first I want to include the header file, and then I will turn these declarations into definitions, into skeletons first, and then I will fill out the blanks. Okay, so for this we of course need a list structure. I will simply call this node because it's an internal structure, so it doesn't have to have a meaningful name. We have a next pointer and a function pointer for the callback function. So this callback function is the list element, and then we need a global variable for the list, a pointer to the head of let's call it simply list. And then in finalize register, I have to do the usual things for adding a new list node to the list. I first have to allocate memory for a new list node. Here I now should actually call finalize exit. I will do this later. So this was the pattern so far. Now I also have to include standard lib and standard IO before I forget it. And then we can continue here. I want to now prepend this node to the list, and of course I want to initialize the list element with the callback function. So for that I can use the usual pattern. I first set the next pointer to the current head of the list, and the callback function is what I get as parameter. And then the new list head is the node that we just created. Now in finalize, we have to call every callback function, so I have to iterate over the list. And this now would be the usual pattern for iterating over the list elements, but we have to be careful here. We have to do a bit more than just calling the callback functions. We also have to release all the list nodes. So we have here a call of free n. If we would not release this list, we would just create another memory leak. Now the problem is, if I release n, then this pointer is no more valid. And the pattern for managing this is that I have here a new additional pointer, which will keep a copy of the next pointer before I release the memory for this node. So this will always be the first statement in a for loop, which is not just iterating over the list elements, but also releasing the memory for all nodes. And then here I simply call the callback function. Okay, then we also have to implement finalize exit, and this is simple. We first call finalize and then we call exit with this given exit code. And that means from now on the pattern for checking whether we actually could allocate memory will be this. We also call finalize exit here. I'm just doing this here. You can do this in all the other places. Okay, and now we have to write a test program for that. Something simple. Some better than nothing test. So I want to print out something, and of course I have to include finalize. And then the callback function foo will just print that it was called. And I want to have another function. So I copy that function bar, which prints that bar was called. And then in main, you will see the usual pattern. First you register some callback functions. So we register foo and we register bar. Then in general we would do something before we then terminate the program. So let's just say first I want to call only finalize, and after that I will also test finalize exit. Okay, then let's see. Okay, so this works. Now let's change this so that we call here finalize exit, which is actually also testing finalize. So with this test program, we will test all functions that we have implemented. Maybe I want to have here a different comment. Finalize and exit. Okay. And also let's check the exit code. Yeah. Okay, and now we can integrate this into our project. Let's begin with the unique strings. Here you will see it's simpler compared to the string class. Here we actually do not need a destructor, we just will register ourselves once. This will be the cleanup function, which will iterate over all the list nodes and will release the list. So here we again have the same pattern that we iterate over the list that will be destroyed. So I need here another pointer for storing the next pointer, keeping a copy of it. Then the first statement will make this copy, and the next is simply releasing the node. And then the typical pattern for making sure that the first time you call a function, something gets done. We have a static bool variable with value true when the program gets loaded. And then in this if statement, the first thing that we do is we set this to false, and then we register ourselves. So I also need here standard bool. Now let's see if this compiles. And then we have to change the test program for unique strings so that we, in the end, call finalize. And of course, we also have to include the header for that. And maybe we also should print out something here so that we actually see whether this works. Okay, now let's see. Okay, was called. And now we can check this on the Linux machine. So I first have to push this to my repository. So just commit all. So support for finalize. Not very meaningful, but it does the job. Okay, now let's switch the terminal and see if we get rid of this memory leak. I forgot to add this header and source file for finalize. Like forgetting an attachment in an email. It's actually possible to merge two commits into one, but it's not recommended, so I simply do a second commit. So now this should compile. Okay, so far so good. And now let's run this test for unique strings again. I'll type in something else, and Control D. And yoo-hoo, no more memory leaks here. But we are not done yet. You saw that in the calculator we have another memory leak from the string class because the lexer is not releasing this memory. And here we first need a declaration for a destructor for one of these string objects. And I will call this release string, not delete string. Maybe I will write something on the website about my strange naming conventions for object-oriented programming in C. So, okay. This implementation is simple. We just release the memory that was allocated. So the only problem is that we have to do here this const cast, of course. But here we already have a pattern to make sure that we do not get a warning, because in this case it's okay to do this const cast. So we allocated memory which is at the head of this pointer, so this gets released by this destructor. Then we also need to include the standard integer types. And let's see whether this still compiles now. Okay, and then of course now in the lexer we have to register ourselves to finalize and then call this destructor. So same pattern. I also have here a cleanup function which is kind of a destructor for an object that is stored in the data segment. So here we simply pass a pointer to this string object. Then I also have to include finalize. And then when the first time get token gets called, we should register ourselves. So again, the usual pattern for that. Okay. And then we want to test this. And here I first have to make sure that we call finalize. And now you should change, of course, all test programs so that in the end you call finalize, even if nothing gets registered. So this is another pattern from now on. And now for testing, I want to see here some printout, which I will remove before I commit this. Just to make sure that I haven't forgotten something. Okay, so the destructor now gets called. And now I commit and push this again to my repository. Make it clean actually, so that I see this time better what needs to be added to the repository. Actually, this test program also should be added now, of course. Okay, now everything is part of the repository. Okay. So now let's see, this also should fix the last problem if we use valgrind to analyze the memory leaks for the calculator. at least all of the problems that we will solve in this session. Actually, I should also call valgrind. Okay, now. Okay, no more memory leaks, but you will see this is not the end of the story. Because if we have some syntax error, we still call simply exit, and then finalize doesn't get called currently. But this is a problem that we will fix with a different design pattern for doing memory management for parsers that create expression nodes. That's it for this video. This last open problem that if we have some syntax error, the lexer is not cleaning up this half-built expression tree, will be fixed later with a design pattern that is usually used in compilers in such situations. What you have to do now is, of course, make sure that everywhere finalize gets called before the program terminates, and that instead of exit, we call this function finalize exit, except in one place, of course. In finalize exit, you still call exit. So that's it.